been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
All right, in this video, we're going to apply triangle sum properties. We're going to look at different types of triangles as well. So first of all, we need to know what a triangle is. It's a polygon with 3 sides, and we name a triangle using its 3 vertices. So for instance, if I have a triangle here, and the vertices are A, B, and C, then I would call this triangle A, B, C, and we literally just use a triangle symbol to say that I'm trying to say that that's a triangle. Pretty straightforward. Now, there's different classifications of triangles. There's classifications based on the sides of the triangle, and there's classifications based on the angles of a triangle. So the first ones here are for the sides of a triangle. So a scalene triangle is a triangle with no congruent sides. So for instance, that side is different than this side is different than this side. So a scalene triangle has no congruent sides. An isosceles triangle is a triangle with at least 2 congruent sides. So for example, this side is congruent to this side, and then that side is not. Notice that it says at least. That means that technically an equilateral triangle is also isosceles. So just be aware of that. If I ask you if something is isosceles, as long as it has at least 2 congruent sides, then it's isosceles. An equilateral triangle is a triangle with 3 congruent sides. So these, again, would be 3 congruent sides. And if that doesn't look equilateral, then sorry. But a triangle with 3 congruent sides. Now we move on to classification based on the angles. Acute triangle is a triangle with 3 acute angles. So kind of like the triangle that I just drew, those are all acute angles. So this is triangle ABC. All 3 of these angles are acute. Now, they're not necessarily congruent, but they're all acute triangles. A right triangle is a triangle with exactly 1 right angle. So it might look something like this, where this is the right angle. An obtuse triangle is a triangle with exactly 1 obtuse angle. So something like this, where this is your obtuse angle, which means it's greater than 90 degrees. An equiangular triangle is a triangle with 3 congruent angles. So something that looks like this, where all 3 of these angles are congruent. Now, what are the interior angles and what are the exterior angles? Well, interior angles probably sounds pretty straightforward. The 3 angles on the interior of the triangle. So if I have a triangle here, so here's my triangle, and I'm going to call this triangle XYZ. The interior angles would be these 3 angles. The exterior angles are going to be the angles that form linear pairs with the interior. So if I were to extend this segment out, then now I have this angle here that is the exterior angle. Why? Because it's a linear pair with the interior angle. Same thing here, I have this exterior angle. And then if I were to extend segment XY out, you could see that I have this exterior angle. Now, if you'll notice, if you extend all of the sides of the triangle out, then you'll have a bunch more angles, okay? But you'll also have some vertical angles. So this angle right here, okay, is not an exterior angle. Why? Because it's actually the same measure as the interior, because it's a vertical angle with the interior angle. So make sure that your exterior angle is not vertical to the interior. It must be a linear pair. We're going to cover the triangle sum theorem and the exterior angle theorem in class, so just make a spot in your notebook for that. We're going to use GeoGebra to explore that a little bit. So you need to be able to classify triangles based on these classifications that I identified here, both with their angles and with their sides. And so it is possible in fact, a triangle will have 2 classifications. It will have an angle classification and it will have a side classification. So if I have this triangle here, okay, so I have this triangle here. What do I notice? I notice that it has 2 sides that are congruent. So that would be isosceles. What do I notice about the angles? Well, it has 2 angles that are congruent. But it looks like all 3 angles are acute, so this would be an acute isosceles or an isosceles acute, either way would really work. Both of those classifications work for this triangle. The last thing I want to do is I want to look at how you would classify a triangle given its coordinates, the coordinates of the vertices, which we have here, or the graph, again, which we also have here. And so if we want to classify this based on its sides, then we need to know the distance. And so we're going to review the distance formula and how to do that so that we can find the length of the sides. So I'm going to go ahead and label this PQR. And so first I'm going to find the distance of PQ. And I would encourage you to try this on your own first to see if you remember how to use the distance formula. So this is going to be 3 minus 2 squared plus 6 plus 1. The reason it's plus 1 is because minus and negative is plus. So 3 minus 2 is 1. So 1 squared plus 7 squared is going to be 1 squared is 1. 7 squared is 49. So this is going to be the square root of 50. So PQ is the square root of 50, which I could simplify that to be 5 square root of 2, because 25 times 2 is 50, and the square root of 25 is 5. So this is 5 square root of 2. So now I'm going to find the distance from Q to R. So QR is going to equal, I'm going to do 3 plus 2, instead of 3 minus negative 2 squared, plus 6 minus 1. Got to make sure you do it in the same order both times. 3 plus 2 is 5, so it's 5 squared plus 5 squared, because 6 minus 1 is 5, is 25 plus 25, square root of that, which is the square root of 50, which, as we just figured out, is 5 square root of 2. So already I have two sides that are congruent, so it's got to be isosceles at least. Maybe it's equilateral. We'll about to find that out. So now I'm going to find PR. So PR is going to be the square root of negative 2 minus 2 squared plus 1 plus 1 squared instead of 1 minus negative 1. Negative 2 minus 2 is negative 4. Now remember, when you square a negative, it's going to be positive anyway. This is going to be 2 squared. Negative 4 squared is 16. 2 squared is 4. So this is the square root of 20, which is the same as 2 square root of 5. So it is indeed isosceles because only two of the sides are congruent. And if we look at the angles, it looks acute, but this angle PRQ, looks a little suspicious, like maybe it's a right angle. Well, we know how to figure that out. If the lines are perpendicular, then it is a right angle. So let's find the slope. So the slope from here is 1, 2, 3, 4 over 2, which is negative 2. So the slope of that line is negative 2. And then the slope of the line that it intersects is 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. That's a positive 1 slope. Negative 2 and 1 are not perpendicular slopes. Therefore, this is not a right triangle. It would be an acute triangle.
I've been waiting way too long. Yeah.